All right, so let's look at some examples of multidimensional structures that we might use. As I mentioned earlier, there are two main reasons that we might want to use a multidimensional structure. One is to read JSON files, which are multidimensional structures. That is, when we say a multidimensional structure, I'm talking about a container within another container. So a list inside a list, a dictionary inside a dictionary, a list of dictionaries. And then the other is just to represent data in our programs. There are a lot of situations where a list or a dictionary really aren't enough to represent the data that you're hoping to hold. And that list of student items with another list nested inside of it is a good example. There's just no convenient way to say this student has this first name, this last name, this city, this state, and these courses. There's no simple way to do that except with a multidimensional structure. But even in two-dimensional data like this, which will provide us with a good simple example, even with two-dimensional data like this, there are ways that we can represent this data that's more convenient than just, say, a list of lists or, an iteration of lists. It might be more interesting to use, for example, a list of dictionaries, and it might be more convenient as well. With a list of dictionaries, each row is represented as a dictionary. And the convenience here, and a lot of the conveniences are actually really, really meaningful to us, because when something is convenient, it means that we just don't have to do that extra little step. With a list of dictionaries in this way, it becomes quite easy to manipulate and list through and read this data. So if we were to, let's say we wanted to see the ID of even every student, we could easily just refer to it as we're looping through, right? So we should see, in this case, each student's ID. And it'd be easy to, obviously add in the F name, etc. Now, you may not see the super convenience of this at the moment, but this is one structure that sometimes comes up. It's also possible to get a database to deliver dictionaries to you for each row. And there are times when we do want to represent the data this way just because it's very convenient to us later on. Remember, in ETL, which is extract, transform, and load, we're pulling data from some source and we're structuring it in a way that's going to be convenient to us. That's the point of ETL, extract, transform, and load. Take data out of somewhere, put it into a form, transform it into a form that's going to be convenient to us, and then load it somewhere else, loop through it, do some other thing with it. A lot of times we're asked to take data from one format and then convert it into another format. And what we use in between is a data structure that, again, is going to be conducive to what we want to do. That's going to be convenient for what we want to do. So we might easily desire a list of dictionaries. Now, looping through this is pretty simple. As you can see, each item is a dictionary. So as you're saying for StuDict and LOD, you get a convenient name of the dictionary that you're working with, and that's easy enough. But I'd also like to ask you again to see if I can challenge you to print out one of the items from within this structure. We might not normally do this directly with a list of dictionaries, but I think it's a good exercise. How would you print the name Bosco from this list of dictionaries in one statement? You understand that that dictionary does have a position, so if you've been asked to just go find that, we actually might be using the other structure that we're going to look at, a dictionary of dictionaries. But let's just, for the sake of the exercise, and don't think that this is what we normally do, let's just ask, for the sake of the exercise, how could you print the name Bosco? I'm going to let you pause and see if you can figure it out. Okay, well, first we need to follow the rules. What are the rules? First, find the location of the structure you want to work with. We don't need to ask about the location of the outer structure, this being the list, the outer list, because we know exactly how to access that. That's through the name LOD. But how am I going to access the inner dictionary, the third dictionary in that list? And the answer is by its address. So what is the address location of that third dictionary? I think you know, because you know this is a 3-item list. The 3-item list is 3 dictionary objects. And so if I want to access Bosco, I'm going to first have to find the address of the structure that contains Bosco. And that is the 3rd item in LOD. So the very first thing I need to do is print LOD2, because LOD2 will be the 3rd item in LOD, and that's going to get me that dictionary. That should get me the interdict with Bosco. I can try it to find out, and I always recommend that you print out what you're doing step by step so that you can be clear on what's happening. And now if I want to access Bosco, I just have to come to the realization that the dictionary that I'm working with, LOD2, is the dictionary. LOD2 is pointing right at the dictionary. So all I have to do is treat it as if it were the dictionary, LOD2. Okay, LOD2 is the dictionary. If that's the dictionary, how do I get Bosco out? I'm going to say LNAME. That should get me Bosco. Bosco, by the way, is also a delicious chocolate syrup. It's not just a person's last name. Okay, that's how we're able to access an inner value within the dictionary. And earlier I showed you how we could loop through this list of dictionaries and print out selected values from each one. That might be more frequently what we would do with a list of dictionaries, because clearly this list of dictionaries is a way of expressing row data just in a convenient form.